Hello students, in the last video lecture we talked about the Poincare Carton integral invariant. Now today we will talk the converse of that Poincare Carton integral. So let us assume over here that it is given the straight line paths which are defined by the system of first order differential equation. So straight path is given by this one, qi dot is equal to capital Qi and pi dot is equal to capital Pi. Okay, where Qi and Pi are the function of T, Qj and Pj, Hamiltonian variables, coordinates. Now, the motion of the system will be defined uniquely on the basis of the initial given value. Okay, so for the initial given value, we will give the motion should be defined. Now, what else we will assume? We assume that the Poincare Carton is integral is invariant along the closed curve. That means it is given, we have proved that integral along the, if there is a tube, what is this tube? The genetics of the tube is these straight lines. Okay, so if we find out the integral along the closed curve around that tube, so that integral will be invariant. What was that integral? That was the integral along the closed curve. It was summation pi delta qi minus h delta t. Okay, so that summation, that is 0 to 1, that summation will be invariant when you taken along the tube, when you taken along the closed curve around the tube. So it is written over there, right? Now what are the straight line? These state genetics are the straight line, and straight line is given by this one. Assume that straight line is given by this one. Now what you have to prove over here? We have to prove that the equation in the term of h and capital Qi and Pi. So that means what you have to prove? You know that Qi dot is equal to curl h over curl Pi. So I will say that will be equal to curl h over curl Pi. Okay, that means you have to show that capital Qi is equal to curl h over curl Pi. Okay, and Pi dot is equal to, this is Pi dot, so Pi dot is equal to minus of curl h over curl Qi. Okay, so that means you have to show that capital of Pi will be equal to minus curl h over curl Qi. So this is the thing which you have to prove. Okay, so these are the things which we have to prove, right? That means you have to prove the equations which are the Hamilton equations, you know. So for this proof, we assume that we introduce some variable over here, mu, and we are rewriting the equation number 13 which is given over there, equation number this 13. So I am rewriting this equation as, this is dqi over dt is equal to qi and dpi over dt is equal to pi for I equal to 1 to n. I am rewriting it dqi over capital Qi is equal to dt, and from here also it will be dpi over dt, the dpi over capital Pi is equal to dt. So that means both the value is equal to dt. So all these value dq1 over capital Q1, dq2 over capital Q2, dqn over capital Qn will be equal to dp1 over capital P1, dp2 over capital P2 is equal to dpn over capital Pn is equal to dt. Okay, so that will be the equations. This will be the equations equal to dt, and I am assuming that we are introducing some new auxiliary variable mu such that these equations will be equal to some pi into du mu. Okay, where pi is some arbitrary functions of the Hamilton variables I am assuming. Okay, so this is the arbitrary function of the point in the extended phase space. Extended phase space, that means the coordinate will be t, qi and pi. Okay, now if you integrate these equations, so when you take the integration, we will find the expression for all these q1 q2 q3 qn and p1 p2 p3 pn. That means you can say that we will get the value of the q1 q2 q3 qn and p1 p2 p3 pn in terms of the auxiliary variable mu and the initial given values. Initial given values are qi dot, pi dot and t naught. You know that this capital Qi is a function of t, qi and pi. So when you take the integration, that becomes the function of mu and the t, qi, pi. But you have to find the value of this, all this value in terms of the initial values, which are this one, and the variable mu. So you will say that the value of q1 q2 q3 qn and p1 p2 p3 pn and t in terms of mu and the initial values. So that will be this one. Okay, qi is a function of mu, qj naught, pj naught, t naught, pi is also a function of these variables and t is also a function of this variable. Okay, so now you say these are the parametric equations for the family of the straight line path. Okay, but we need only those straight line path. You know that these are the parametric equation for the straight line path. So if you take some point and you say that the straight line paths from that point, there will be the straight lines. Okay, but you have to consider only those straight line path that form the tube. Okay, if I take that point and you have to take that straight line path that form the genetics of the tube actually. Okay, so we need only those straight line path that form the given tube. Okay, if we have to choose the initial point on the curve C naught. So if there is a curve C naught and we take initial point on the curve C naught, suppose this is M naught. So M naught is a function of qj naught, pj naught and t naught. So if you are taking that point on the curve C naught, so this coordinate will also be a function of the parameter alpha because you are taking along a closed curve. So that points will not be fixed, that will be a function of alpha. So qj naught, pj naught and t naught, that will be a function of alpha, right? So in place of this thing, I will write down these are the function of the parameter alpha, right? Now you have to find out the parametric equation for this genetics, that genetics that is generating the tube. So what will be the parametric equation for this genetics? That will be given by qi is a function of mu alpha, pi is also a function of mu alpha and t is also a function of mu alpha. So what is mu here? So what is mu and alpha here? So here alpha, you can say that suppose that C naught and alpha is a definite straight line path. You can say that if there is some value of alpha, so for that you will get some straight line path, this one suppose. Okay, and what is mu? That mu is a some fix a definite point on this path. Okay, so this is the path and at this point you are taking somewhere there is mu. Okay, so similarly if you fix that mu, suppose that mu is constant. If mu is constant, so there are so many genetics. Okay, there are the genetics. So if mu is constant, so you say that for mu is constant, so for different values of alpha you will get mu is constant everywhere, means mu is constant on every genetics on the tube. So you will get that closed curve, that will be arbitrary closed curve. Okay, so when you take this mu is equal to constant, so over here that it will be a line integral along the corresponding closed curve when mu will be equal to constant. Okay, so that means in the integral, what was that integral? That I was this thing, summation pi delta qi minus h delta t. So over here, if you are considering mu is constant and alpha is a fixed, alpha was the given value. Okay, so value of the alpha was given. So that means this I becomes a function of mu. If this I becomes a function of mu and you are considering mu is constant, if mu is constant, so if you find out the derivative of I, so since I is a function of mu and mu is constant, so the derivative of I with respect to mu, that will be equal to 0. Okay, if d of I is equal to 0, and you know that I was this one, right? So what will be d of I? So d of I will be equal to d of this thing. Okay, so when you find d of this one, so it will be given by this one. So in this way, that will be d of pi delta qi as it is plus pi as it is d of delta qi minus of d of h delta t as it is minus of h as it is d of delta t, right? So it will be given by this one. So what will be? You have to observe here, this d and delta are the differentiation actually. So d is the differentiation with respect to mu, and this delta is the differentiation with respect to alpha. So there are the two differentiations over here with respect to mu and with respect to alpha. So these are differentiation with respect to two independent variables. So you can say that either you are writing d delta or you are writing delta d, that will be same. Okay, that can be interchanged. So this thing can also be written as, in the next line if I write, so this thing will be as it is, that will be plus pi into delta of dqi. Okay, and this term will be as it is over here. Now this term, last term will be minus h delta of dt. That can also be written like this, delta of dt. Now there is one crucial step you have to be remember, one result. If there are any two arbitrary function, I am writing over here, suppose that there are u and v are any two arbitrary functions. So for these two functions, integral along a closed curve, so u into delta v will be given by minus of integral along the closed curve v into delta u. Okay, so that means this delta will be interchanged over here and the negative sign will be applied. So that means u into delta v will be given by minus of integral closed curve v into delta u. So similarly, when you apply over here, so what is this one? This is the closed integral along the closed curve, this one. So and this also here, integral along the closed curve. So when you apply this result over here, so what you will be obtained? You will be obtained that will be delta will be applied to this thing. Okay, so it will be minus sign will be there, minus of delta of pi and dqi, right? Like this, delta is पे apply हो जाएगा, v as it is. Similarly, when you apply this result over here, so it will be minus minus plus, and that will be integral this along the closed curve, that will be delta of h into dt. Okay, so this term is written over here, you can check that term as it is, we apply this result is here, that term as it is, and this result is over here. Okay, let me rub it, you will understand. So I got the result from this, I got the result here, and from this I got the result from here, right? So now you know that what is h. H is a function of Hamilton function. This is a function of Hamiltonian variables t, qi and pi, right? But you need here delta h. So delta of h will be given by what it will be? It will be curl h by curl t into delta t plus summation curl h over curl qi delta qi plus curl h over curl pi into delta pi, right? And into dt is also there. So multiply by dt, if you apply in multiply dt, so everywhere that will be dt, dt, and over here dt also. Okay, so that means you can check that these terms were there, and we apply this will be equal to these three terms. Okay, so you can check that in the first term delta qi is present here, and in the second term is also from here delta qi is common. So what I can say that summation is there. So I write down the summation d of pi, delta qi I take common. So it will be d of pi, and that will be curl h over curl qi into dt. So curl h over curl qi into dt. Okay. And now if you take delta of pi is common here, and here also delta of pi. So delta of pi if you take common, that will be minus of dqi and plus curl h over curl pi into dt, that will be here. Okay, del pi. And remaining term delta of t over here and delta of t over here, if I take common, so it will be minus of dh, that will be minus of dh, and plus remaining term curl h over curl t into dt. So curl h over curl t into dt, right? So when you take this common, in this way it will be written like this, right? Now you can observe that. So from here you can observe this value will be given. Okay, this term is equal to 0 here. Okay, so what I do here, now I divide the whole integral term by d mu. But you know that what was that? Dt is equal to, when I introduce this mu, so I assume the system of the equations will be equal to dt is equal to pi d mu. Okay, so from there you can say that value of d mu will be equal to dt by pi. Okay, so I am dividing the whole terms term wise, this and this, the whole terms I am dividing by dt by mu. Okay, so when the terms will be divided by dt by mu, so this by dt and mu in term multiple, this by dt, so dt will be cancelled out, pi will be multiple. Okay, so that will be dp by dt. So you can check that it will be some, let me write, it will be dp by dt into pi, and it will be, when dt will be multiple, so that dt will be cancelled out. Okay, when divided by dt, and pi I am taking outside. Okay, and this by dt by pi, so this by dt and pi I am taken outside, and this divided by dt, so this will be cancelled out, and when this divided dt, that will be dt, when this divided by dt, that will be cancelled out, and pi will be taken outside. Okay, so that means that part will be left here, so which is written over there. Now you know that what was the equation dpi in the first assumption. We have taken the system of the differential equation pi dot is equal to capital Pi and qi dot is equal to capital Qi. So this is pi dot. So in terms of this, I write down the capital Pi and plus curl h over curl Qi into dq, right? And this is Qi dot. So this Qi dot I will write down as capital Qi. So I write down it minus capital Qi plus remaining as it is curl H over curl Pi into delta Pi, and this will be minus dH by dt plus curl H over curl T into delta T, and pi is there. Okay, but when I introduce the auxiliary variable mu, I taken that pi as a arbitrary function. Okay, when the pi is arbitrary, so you will say that this integral is equal to 0, but pi is arbitrary. If pi is arbitrary, so that should be 0, that bracket term should be 0. For this bracket term should be 0, this term should be 0, because delta Qi, delta Pi and delta T are independent. So that means these coefficients should be equal to 0. That coefficient should be equal to 0 means capital Pi will be equal to minus of this is equal to 0 means capital Pi will be equal to minus curl H over curl Qi. This will be equal to 0 means Qi will be equal to curl H over curl Pi. Okay, and that means this is equal to 0 means dH by dt is equal to curl H over curl T. Okay, so this result we have already studied before in the videos lecture. You can check this result already hold, and for this what we have to prove, we got the result. Okay, that means the Hamiltonian equations I got. Pi, capital Pi will be equal to minus curl H over curl Qi, and capital Qi will be equal to curl H over curl Pi. So in this way we got our required proof. Okay, so the next topic we will discuss in the next class. Thank you very much, students.